Introduction to linear relations. That will be the topic of today's video. Okay, so our learning goals for today, we have quite a few as you can see. So by the end of the lesson, you should be able to recall the definition of a linear relation, identify and construct a Cartesian plane, also known as a number plane, identify the x-axis, the y-axis, and the origin on a Cartesian plane, plot coordinates onto a Cartesian plane, state the coordinates of a point from a point plotted on a Cartesian plane, identify the x-coordinate and the y-coordinate from given values, recall what the x-intercept and y-intercept are, and your last goal is to identify each of the 4 quadrants on a Cartesian plane. So quite a few goals, and we'll go through them all during this video. Okay, so a Cartesian plane, we've got an example of one on the right here, is also called a number plane, as I've said, and it consists of 2 axes which divide the Cartesian plane into 4 quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So those are the 4 quadrants of our Cartesian plane. So as I said, we have 2 axes. We have the x-axis. So the x-axis is the horizontal axis, and then we also have the vertical axis, and that's called the y-axis. And where those 2 axes meet in the middle here, this is called our origin. And our origin has the coordinates 0, 0. So it's 0 on the x-axis and 0 on the y-axis. So a point that we plot on a Cartesian plane is plotted using a coordinate pair. So if I plotted a point right here, we could actually get the coordinate pair. So the coordinates are written in that format x, y, where x is the position on the horizontal axis. So if you look on our horizontal axis here, you can see it's above the 2. So if we went straight up from the 2, we would hit our point. So the x coordinate would be 2, and the y describes the vertical position from the origin. So the vertical position, again, if we went across, it would also be 2. That was a bad example of 2, 2. Let's plot another one. So let's plot a point, let's go here. Okay, so if we were to plot this point and give the coordinates, the x-coordinate would be, if we go down from the x-axis, it's going down from -2, so it'd be -2, and if we went across to the y-axis, we'd be hitting here at -5. So you can see the coordinate pairs there of those various points. Okay, so a linear relation, remember one of our learning goals was for you to recall what a linear relation is. It's a set of ordered pairs in that x, y kind of format, and when we graph them together, we get a straight line. So it has to be a straight line for it to be a linear relation. So the x-intercept is where the x-coordinate, is the point where a line of that linear relation actually cuts, x would go this way, sorry. It's the position where the line on a graph would cut our x-intercept. So in our graph here, this would be the x-intercept, because you can see this is our line here of our linear relation, and that's where it cuts that x-intercept. That's where it cuts that x-axis, and that's called the x-intercept. The y-intercept is the y-coordinate at the point where the graph cuts the y-axis. So you can see right here, it's cutting that axis. So the x-intercept in this example here would be 2, because that's the point where it cuts that x-intercept, and the y-intercept would be 4, because that's where it's cutting that y point in the graph. In a table, you can see it here. The x-intercept is the value when y is 0, and the y-intercept is the value when x is 0. Okay, so we're going to do a bit of an example. So using the values from -3 to 3, so x being equal to or greater than -3 and equal to or less than 3, we're going to construct a table of values and plot the graph for that linear relation. So we are given a formula here, y equals x plus 2. And I'm going to show you how we'll go from that formula to a table to a graph. So we've been told our x has to be -3 or greater, so -2, -1, 0. And on the other end, we were told it has to equal 3 or less. So 1, 2, 3. So that's what we've got for our x values. Now we know our formula is y equals x plus 2. So it's just a matter of putting our values of x into that formula. So for instance, y equals x plus 2, and our first x value is -3. So -3 plus 2 equals -1. Our next one, y equals -2 plus 2 0. I'll get a eraser and rub this out. Now, in an exam situation or in your book, hopefully you'd have a little bit more space than what I have on this slide. So you could set this out properly going down the page for each of your values. But obviously I'm a bit limited on this slide, so that's why it's all cramped up. Please don't do what I do. Set it out properly. So y equals -1 plus 2 equals 1. So if you've done the first 3, you can actually start to see a bit of a pattern happening. So we can see as our x value is increasing by 1, so is our y value for this pattern. So you can just follow that pattern if you would like, and just increase it by 1 each time, because you can see that pattern is going to continue. And we know it's going to continue because it's a linear relation. It tells us in the question it's a linear relation. So it's going to be a straight line. So that corresponding change in y as x is going to continue in the same pattern because it's a linear relation. If it wasn't a linear relation, for instance, if we were plotting a parabola or something like that, we couldn't follow this pattern. But because it's a linear relation, we know it's a straight line, so it's going to continue with that pattern. So the next step is once we've filled out our table, it's to plot each of those points onto our graph. So we can take these as coordinates. So for instance, our first coordinate would be -3, -1. Our second one, -2, 0. And then our third, -1, 1, and so on. So we can plot each of those as points on our graph. So the first one, our x is -3. So we're going to find, this is our x-axis, this is our y-axis. So we're going to find -3 on our x-axis, which is here, and our y is -1. So we're going to drop down to find -1. That's our first point. Our second point, x is -2, so we found that, and y is 0. So that is here, and that will be our x-intercept, because you can see at -2, that's where our line will cut that x-axis. Our third point, x is -1 and y is 1. That's here. Our next one, x is 0. So we know this must be our y-intercept because x is equal to 0, y is equal to 2, so our y-intercept there will be 2. Our third one, x is 1 and y is 3. We've got 3. X is 2 and y is 4. And x is 3 and y is 5. So we'll go like that. So you can see we've got all our lines, coordinates plotted. They are forming a straight line. So that's a good sign, because if you are plotting a linear relation, you do want it to be a straight line. So make sure you check that. If it's not a straight line and it's told you it's a linear relation, obviously something's gone wrong. So then your next step is to get your ruler from your point. Ooh, my ruler is not working there. So use your ruler and join all of your points together. So that is going to be your line, and you are going to label that, and the label is going to be the rule that you've used to find it. So y equals x plus 2. Now, you can obviously continue this all the way off the graph if you like, because obviously that rule is going to fit for the whole graph. Okay, our second example, again, we're going to use x values of less than or equal to -3 and greater than or equal to -3 and less than or equal to 3 to construct a table of values, and again plot these onto our graph paper there. So -3, -2, -1, 0, 1, 2, 3. And then we can use our formula to fill in our values for y. So y equals 2x, and x is going to be -3 times 2 plus 2. So -3 times 2, a negative times a positive is going to give us a negative. So -6 plus 2, -4. -4. For our second one, we've got y equals 2 times -2 plus 2. 2 times -2, positive times a negative is going to give us a negative. So -4 plus 2 equals -2. Get my eraser. Actually, I'll just clear that, rewrite it. -4, -2. Oh no, I cleared everything. -2, -1, 0, 1, 2, 3. Okay, so now we've got y equals 2 times -1 plus 2. It's going to be a negative. 2 times 1 is 2 plus 2, 0. Okay, so we can start to see the pattern again. This time, as x increases by 1, y increases by 2. So this will give us 2, 4, 6, 8. And from there, we're going to plot these points again. So our first one is -3, -4. So we're going to find -3 on our x-axis. So go to -3, which is here, and then y is -4, so we're going to drop it down to -4, put our dot there for our first point. Second one, x is -2, so we find our -2 on the x-axis. Y is also -2, and then we drop it down to find that -2. For our next one, x is -1 and y is 0. So this would be our x-intercept here. So our x-intercept would be -1. Our next one is going to be our y-intercept, because we can see x is 0. So that's x is 0 is there, and y is 2. So we're going to go up to the 2. So our y-intercept would be 2. Our next point, x is 1, sorry, and y is 4. So we find the 1, go up 4. There we go. Our next one, x is 2 and y is 6. Oh, I've run out of space on my graph for our last point. So hopefully, if this was in your book, you would actually rule up a graph that is of a suitable size. If it wasn't, I would expect you to fix that. So I'm going to add a little bit more onto this graph. It's not going to look very professional, but you'll get the point. 6, 7, and 8. Okay, so x is 3, so you find 3 on the x-axis. Y is 8, so you go up to where it says 8. Draw your line. Check that it's a straight line. Yes, if I connected all those points, it would be a straight line. And then you would get your ruler and you would connect all of the points together to form a straight line. Once you've formed your straight line, again, you can continue it to the edge of the graph if you'd like, and you're going to label it with the rule. So the rule is y equals 2x plus 2. Also, your linear relation will have a straight line. Just with the technology I'm using, it's a bit hard to use a ruler. Doesn't need to get into it, but use a ruler in your own books. Okay, our next worked example is write down the x-intercept and the y-intercept from this graph and table. Well, that's pretty easy. So for our table there, I'll answer it down here. So A, x-intercept. So we know our x-intercept is the point when y equals 0. So we look for the table. Where does y equal 0? Oh, that's here. So our x-intercept is obviously going to equal -2. And our y-intercept is the point where x equals 0, because that's where it's going to cut the y-axis. So x is 0 here, so y is 2 as well. So our x-intercept is -2, our y-intercept is +2. For B, we can just look at the graph. So for our x-intercept, where does it cut the x-axis? So remember, x is our horizontal and y is our vertical. It cuts the x-axis here. So the x-intercept, oh, it's going to be -2 again. And where does it cut the where does it cut the y-axis? That will be our y-intercept. And we can look at our graph and it cuts it here. So y is 2 again. A bit of a coincidence there. It won't always equal 2. It just has for these two examples. Okay. Our next worked example is finding out whether a given point will actually fit with a rule. So the rule for our first one is y equals 2x plus 10. So if we were to draw up a table of values, work out what x and y are, and then plot that onto a graph, with this point here, -2, 4, would actually fall on that straight line that we've graphed or not. So you could draw up a table of values, work out what x is and what y is, and we could plot those points onto a graph, and then you could see if that point falls onto it. Or there is an easier way where we can actually just substitute these values in, because we know coordinates are given in the x, y format, so we know a value for x and we know a value for y. So we can substitute those in to actually see if they would fall on the line that could be plotted with those rules. So what we do is we'd substitute in our x value. So the rule is 2x plus 10, and in this case, x is going to equal negative 2. So 2 times negative 2 plus 10. So we're going to solve that. 2 times negative 2 is going to give a negative number. 2 times negative 2 is going to give us negative 4 plus 10. So then we're going to add negative 4 plus 10 will give us 6. So that's saying y equals 6 in this rule if x equals 4. If x equals negative 2. So if x is equal to negative 2, according to this rule, y should equal 6. But our given point has y equal 4, so that means it doesn't fall on the line. So no, doesn't fall on the line. Okay, so the first one was a no, and then for B we're going to do the same thing. We're going to substitute those values into the rule and see if we get an answer that corresponds with the points that we were given. So for our second one, we've got y equals negative x plus 2. And remember, our points are given in x, y, in an x, y way, and we've got negative 2, 4. So obviously x is negative 2, y is 4. So we'll substitute x equals negative 2 in, and hopefully we'll get a value of 4. If we do, it means it does fall on the line. If the y doesn't equal 4, it means it doesn't fall on the line. So negative 2 plus 2, add those together. Negative 2 plus 2 is equal to 0. So no, again, it doesn't fall on that line either, because when x, negative x. Oh, sorry, I did a mistake there with my math. So let's clear that up. Sorry, I substituted in wrong. So it's negative x plus 2. So negative, and our x is negative 2. So negative times negative is a positive, so it should be 2 plus 2. Y equals 2 plus 2 is 4. So yes, actually, it does fall on the line. Sorry, did my maths a bit wrong there. So our second one would fall on the line in that case. So the first one's no, second one's yes. So our second value, we know it does fall on that line because when x equaled negative 2, y did equal 4 according to this rule. So because we got those same values, we can see that it would fall on that line. Hopefully that's clear for you there. If it's not, make sure you do come and ask me for help in class.